Hello dear friends and welcome to this video. In the previous video, we learned about scheduling tasks for repeated fixed delay executions using the Threads API. In the current video, we will learn what repeated fixed rate executions are and how to use the Threads API to schedule tasks for the same. You already know that timer and timer task only will be used here. There are two overloaded methods available in the timer class for scheduling repeated fixed rate tasks. Schedule at fixed rate. The parameters taken by these methods are exactly the same as discussed in the previous tutorial for the repeated fixed delay methods. Only the method names are different here. Similarly, here also the next execution of the task is scheduled when the current one begins. But here the next execution is scheduled relative to the scheduled start time of the very first execution. So the second execution's scheduled start time will be one period later than the first scheduled start time. By period, I mean the parameter specified in the schedule at fixed rate method. The third execution's scheduled start time will be 2 times the period later than the first scheduled start time. The fourth execution's scheduled start time will be 3 times the period later than the first execution's scheduled start time, and so on. This means that the scheduled start times of two successive executions differ exactly by the specified period. So we do not see any drift in the scheduled start times and hence the actual start times over long runs like we witness in the repeated fixed delay executions. This also means that the frequency of executions stays constant over reasonably short as well as long runs. Hence, repeated fixed rate executions are suitable for those activities that are sensitive to executions at absolute time, like hourly chimes in clocks or running maintenance tasks at particular times. Such executions are also suitable for recurring activities where accurate frequency of executions is to be maintained, like showing a clock on screen or showing a countdown timer where it ticks every second or every millisecond. Lastly, such executions are also useful where different types of tasks must remain synchronized with respect to one another. Coding time. As the code is exactly the same as the repeated fixed delay executions, I have just copied that class to create this one. The only changes that we need to make here are in the names of the scheduling methods. Here we have to use the schedule at fixed rate methods instead of schedule methods. Let us run this class now. We see that the scheduled start times of both the task streams is exactly 2 seconds apart for two adjacent executions. For the first task, the first scheduled execution time was 21:06 and 32.474 seconds. Its successive scheduled times are 34.474, then 36.474, then 38.474, 40.474, and so on. Here, each successive scheduled time is 2 seconds later than the previous execution's scheduled time. Similar results are there for the second task also. The first run was at 33.476, the second at 35.476, the third at 37.476, the fourth at 39.476, and so on. Lastly, after 16 seconds, the main thread cancels the timer and dies. After that, the timer execution thread also dies and the program terminates successfully. That's all for this tutorial. Thanks for watching it. Starting from next video, we will start looking at how to schedule tasks using the Executors framework. Till then, keep learning, keep practicing. Bye.